Hey everybody, and welcome to this demonstration of ingestion functionalities in Dremio. So this is not a end-all be-all of the different ways you can create a table in Dremio, but I want to show you some of the more fun ways that might be useful for definitely different types of workflows. Now, of course, it's Dremio's catalog, and again, Dremio's open catalog. When you're on a Dremio Cloud account, you can see right here, this section that says namespaces. This namespaces, that is the Dremio catalog, the Dremio open catalog, powered by Apache Polaris. So it's an Iceberg catalog, a lakehouse catalog where you can organize your data. I got all sorts of stuff going on there now, but you can land data in there, not just from Dremio, but from any tool that can land data as Iceberg. You would just connect to the Dremio catalog using the REST catalog interface, and you'd be good to go. But Dremio has lots of functionality that you can take a leverage for getting data into those Iceberg tables in this catalog. And I'm going to show you a few of those. Now, what I've seen in a lot of companies is sometimes people just like to upload a file. They like to upload a CSV file that they exported from Excel, or they like to upload a JSON file or a Parquet file. And they want to just run ad hoc analytics. And you can do that in Dremio. You can do that as easily as just clicking down here to click on Add Data. And you can go here to drag and drop, and you can choose a data file. So right here, I'll just choose this random CSV file right here. Okay, we'll just call this data. And then I can choose where I want this to show up in my catalog. Okay, right now what I'll do is I'm going to add a new namespace for uploads, just so that way to organize. And I'll say, hey, you know what? I want all my uploaded files in this upload space. That way I know where my file uploads are landing. Okay, so then I'll just select that file upload namespace. I'll hit save. Okay, and now I get to choose sort of what file format. So I can say, hey, what kind of, is it a CSV file, a JSON, or a Parquet? It automatically detects that it's a CSV file. It detects that it has a header column, so it's extracting the column names. And as long as this looks about right, we're good to go. And I can go in and I can create the table. And what it's actually doing is actually just taking that CSV file and automatically taking it and turning it into an Iceberg table in my catalog. So now that data is an Iceberg table, okay, which I can now query. Okay, and I can go over here, run a query on that handful of records. Now, generally, you're probably going to want to do this on larger files, but again, this is for demonstration purposes. Now, what if you have a whole bunch of CSV files sitting on S3? So for example, I have an S3 source connected here. So I'm going to go over here. I have a bucket for my demos. Okay, and then if I go in here, see I have this copy into example folder where I have a bunch of CSVs. Okay, and since we're here, let me also point out that I have this PDF example folder with several PDFs, which we'll be using a little bit later on. Okay, but the cool thing is what I can do is I can use the copy into command, okay, in Dremio, and that's going to allow me to target a specific like folder in with files, or in an individual file. But in this case, I'm going to target a whole folder of CSV files and say, hey, you know what? I want to take those CSV files. I want you to take those records and add them to an existing Iceberg table. So let me copy over this script. Okay, so in this case, what I'm doing is I am going to create a folder for us to land this, where I'm going to make this table. Then I'm going to actually create the table. The reason why it's important to create the table first is because CSV, it's going to assume that all the columns in a CSV file are text. But the beauty of copy into, since the table itself already has a schema, this transactions table has a schema, it can automatically convert the CSV's columns into that schema. Okay, so it'll basically coerce the CSV into that schema, so we don't have to worry about doing sort of data type changes later and all these alter statements. We're just cutting right to the chase, real convenient. So then here I'm just saying, hey, copy into this new table from this particular folder in my S3 source. Basically, get and look for all the files that end in CSV. They should be CSV files, and here's some details about how to interpret those CSV files. Okay, that way if you had like a tab delimited CSV file or some other delimiters, you have that flexibility. And then I can just run this and let's watch it go. Okay, so first it's going to go create the folder. Now it's going to create the table. And now it's going to begin reading those CSV files, turning those into records that it can then basically add to that table. And that's done. So now if I go back over here, back to my catalog, I'm going to head over here to Dremio, go to the copy demo. And there's the transactions table, and I can query the data. Okay, and you can actually set it up. There's another feature called copy pipe, or create pipe. And what it does it creates sort of a regularly running copy into. So this copy into command, if you have like a folder where Parquet files or CSV files or JSON files are landing on a regular basis, and you want to have a continual sort of job taking those files and adding them to an Iceberg table, there is a feature for that in Dremio called create pipe. That'll do that. But you can see we added those files from the CSV file. Now for the super fancy thing to show you, I want to show you AI generate. So the idea here is, remember those PDF files? Now PDF files aren't structured data, so I can't really run a SQL command across those files. Now what Dremio does allow you to do is allows you to list files in a bucket. So let me actually first show you that. Okay. So in this case, let's see here. So if I were to do select star from and essentially I use the table function, which just says, hey, make a table out of what's inside what I'm passing to the function. This list files function is then going to basically create a list that then turns into a table. So what happens when I run this query, I'm going to get a list of files in that particular folder in my bucket. So there's the 3 PDF files. And it has information out of those files. But again, they're not, but there's data in those files, okay? There's actually like names of people, their ages, their birthdays. And I want to put that in a table. Okay, what I can do is I can use this pattern right here. Okay, so first we're going to do is, again, create another folder for us to sort of organize everything. Then I'm going to create a table called people. But what I want to do is I want to use this AI generate function. So I'm saying, okay, hey, for my columns, there's going to be 2 columns. The first column, I'm just taking the path from this JSON here. So again, you saw that list files just gave me that 1 column file, which has this sort of this struct right here. And I'm just going to take the path value as one of the columns in my new table. The second column is going to be the result of this AI generate function. So this AI generate function is going to return a struct with a schema that I want for every file that I pass it. So in this case, I'm saying, hey, you know what? I want you to extract these values for every file. Now the schema that I want every row you return me to have is this. Okay, and then the name of this column with this struct is going to be called extracted. Now where are you getting this list of files? Well, from the list file, from that list that we got from list files. And again, I only want to scan the files that have PDF at the end. So now if I run this, what it's going to do now, it's going to, again, create that folder. And now it's going to create a table based on the results of that query. The results of that query are, again, going through each Parquet file, each PDF file, interpreting the PDF file using AI to get structured results. And then here we go. So again, I just took a bunch of PDF files, and now I go over to Dremio AI generate example. Let's query the actual table. There should be 3 records because I was 3 PDF files. Okay, and there we can see the results. Okay, we can see that we got that first name field, we got that age field, and we got that birth date field. Then I can, further flatten it afterwards using Dremio's semantic layer, create like a view that flattens out these fields, and so forth. Okay, or I could do something like this. I could say, hey, you know what? Select extracted name as name. Okay. Oh. There we go. Well, you get the idea. Basically, I have to typecast it, but how to typecast it is escaping me at the moment. But yes, okay, so there you go. We've extracted this structured data from PDFs. And again, imagine you have a bunch of forms you want to fill out. Instead of having to separately create a separate AI process or a separate pipeline to take all those PDFs and then turn them into data, and then separately ingest that data into an Iceberg table, you can just skip all those steps, go directly to the Iceberg table using functions like AI generate. So what we learned today, we could, for ad hoc workflows for that employee who just kind of likes to upload their quick files to run some SQL files against, you can upload a file. For, those buckets where you have loads of CSV, JSON, Parquet files, you got copy into to help you get that data into an Iceberg table. And for unstructured data like PDFs and images, Dremio can leverage functions like AI generate, AI complete, AI classify that help you generate structured data from your unstructured data so you can run analytics on that data. All of this is just with Dremio. And again, the catalog is a Iceberg catalog, so you can use any tool you want to land that data in Iceberg, and then you get all the nice features of Dremio that are helping accelerate your queries and help deliver it for your business line analytics. Thank you very much. I hope you guys enjoyed the demo. I'll see y'all later. Have a great one.